In this video, we want to find the limit as x and y approach 0, 0 of 4xy over x minus 2y squared. First thing to do is to plug in x and y equal to 0, and this is not going to work out because you have 0 over 0, and so we need to see if we can simplify this expression. Unfortunately, we cannot use any algebra to simplify it, so our best bet is to show that the limit doesn't exist. And in order to do that, we have to take different paths. The standard paths are usually x and y equal to 0, but that's not going to work here because you end up with the same limit. So the approach that we need to take is that x cannot be, or rather, we want to get rid of the denominator. If we can get rid of x minus 2y squared and replace it with another term, then that's a good path to take. So we're going to take the path along x equals 2y squared plus ay cubed, where a does not equal 0. What this does is the 2y squared will cancel out with the 2y squared, and then we're just going to be left with ay cubed in the denominator. So we substitute x equals 2y squared plus ay cubed. We simplify. On the top we have 8y cubed plus 4ay to the fourth, and the denominator is just ay cubed. We can factor out a 4y cubed from the top, and we're left with 2 plus 4ay. The y cubes are going to cancel, and so we're left with 8 plus 4ay over a. And when we plug in y equals 0, 4ay goes to 0, and we're just left with 8 over a. So that's the limit. Now, the limit depends on the value of a. Since we can choose different non-zero values for a, say a equals 1 or a equals 2, we can obtain different limits along different paths approaching 0, 0. So since we have found different paths approaching 0, 0 that yield different limits, we can conclude that the limit as x and y approach 0, 0 does not exist.